Welcome back. Continuing with lecture 1, the object oriented paradigm. Notice we are learning Python. Okay, Python is a highly object oriented language. What this means is instead of going through merely a sequence of commands, you can use objects. Okay, within an object, there are certain properties and there are certain functions. So let's understand it's easier to play with the objects than completely explain, but this part of the lecture might get a little dense, but bear with me here. Okay. Object oriented programming, or OOP, is the process of modeling data and operations in a paired form rather than as separate entities. Objects of the same class share a common encoding of their underlying data representation and support a common set of operations. Okay. So, for example, look at um, all the teachers. All the teachers have certain commonalities. They teach different classes, but they teach classes. They get paid, or they hold office hours. They have offices, which is different from all the students. Students take classes, right? Students pay for their classes. Students don't have their own office spaces, okay, typically. So that's what this means. Objects of the same class share a common encoding of their underlying data representation and support a common set of operations. Okay, this will get clearer as we go forward. A single object from a given class is termed an instance of that class. Internally, each instance is represented by one or more pieces of data called attributes or data members or fields or instance variables. They all mean the same thing: attributes, data members, fields, instance variables. For instance, Jane equals person, quote F 25 32,000 is an assignment. You see, let me go to my Python shell. If I tell you x equals 5, you understand this. If I tell you y equals 10, you understand this. If I say add x and y, you understand this even though add is not defined. Okay, add is not defined, but what is defined? X plus y. Now that's defined. You understand? So these are assignments, and here is an operation. All right. Now suppose I want to do something similar. That is, I want to be able to create, just as I assigned number 5 to variable x, I want to be able to say, let me assign data of this person 25 32,000. Okay, I want to be able to assign all of this information to one variable Jane. Okay, so why would you want to do that? Say you are a business owner, right? You have many employees. This is one employee who is female, who is 25 years old, whose salary is 32,000. Okay, pretend. So that's what you want to be able to do. Jane equals somebody. Okay, right now we don't know what person means. That is, we haven't encoded, but we want to be able to do this. Likewise, suppose let's see, Jen equals person F 25 32,000. Now look, Jane and Jen are different persons. All right, they are different persons who work in your company. They are both women. They are both 25 years old and they are both being paid 32,000 per year. So doesn't mean they are one and the same person. They are two different persons. Okay. So that is what it is. A new object is created when we invoke the constructor person. Okay. Now what do we want Jane and Jen to have? Well, Jane has gender. Let's call it Jane dot gender is F. Jane has age 25. Jane dot age is 25. And Jane is being paid annual income of 32,000. So Jane dot annual inc, okay, is 32,000. Just as Jane has these variables, Jen must also have such variables. Okay. Even then, even though their values are same, they are two distinct objects. So, taken together, the attribute values of a particular instance comprise the state information. State information is what values any of those variables hold at that time. Over time, state information may change. Of course, 5 years from now, chances are Jane and Jen will both be promoted. Maybe they'll have different promotions and their annual incomes will change. So, state information may change over time. Operations, okay? So, just as we had operation x plus y here, you should be able to add to the income, say Jen dot annual income. I want to increase, so I should be able to say Jen dot annual income should be the old income plus 5,000. I want to be able to do these things. Okay, right now I cannot because I don't even know how to code person. So this is what you are going to learn in this course, how to code these quantities. Okay, so the method, or rather the functions of objects are called methods or actions, behaviors, member functions. These mean the same thing, methods. The operations supported by instances of a class are known as methods or actions, behaviors, member functions. For instance, Jane dot vote, no parameters. So this is either a true statement or a false statement, I guess. Jane.info, this should give me a lot of information about Jen. Jane.add income, so that's a function for Jane, so we call it a method. 2,000, so you presumably are adding 2,000 to Jane's income. Add 3 to Jen's age, add age, are various methods with or without parameters. Collectively, the attributes and methods of an instance are called its members. Okay, for an instance, it has attributes, it has methods. Together, they are all called members. Note that the object can interact with other objects. Say, in addition to the person class, we also had a dog class. So here is Jane from the person class. Here's Spot from the dog class. Here's a sequence diagram. So sequence diagram means, so this is called timeline. Okay, so chronological lifespan of that object. So here is waiting period. Jane has sent out an call to Spot, asking Spot to sit. So it takes some time for Spot to sit and we return. Okay. Jane then asks Spot to lie down. It takes some time and so on. So the vertical line drawn down from the label represents chronological lifespan of that object. Each solid arrow represents the invocation of a method. Invocation, okay, calling of the method, oriented from the caller to the callee. When a method is called, we say that the flow of control is passed from the caller to the callee. At that time, the caller waits until the callee completes the action. This white rectangle, yes, on the callee side denotes the duration of time when the action is being performed. At its conclusion, the flow of control is passed back to the caller. Okay, so the return flow of control back is diagrammed with a dashed line. Okay, here is another sequence diagram. Jane is asking Spot to fetch slippers. So these are parameters. That's why they are inside parentheses. And Spot is able to bring back red slippers. So this is a return value. Okay. This represents calling a method with a parameter. Presumably, spot.fetch slippers returns a value. The overall agreement regarding the expected parameters and return value for a method is called its signature. Some methods do not cause any return in the object's current state, but are used by the caller to request information about that state. Such methods are commonly termed accessors or inspectors. Okay, and associate the use of a return value. For example, Jane.getAge. What does getAge tell you? Well, it tells me it's going to give me the age of Jane, right? So that is an accessor. I'm able to access Jane's information without changing anything for Jane. So we don't change anything for Jane, but just get information back. Okay, so you're going to receive a return value. Accessor do not cause any change in the object's current state. On the other hand, a method that affects the state of the callee is called a mutator. For example, Jane.addAge. Adding age. What does that suggest? I'm going to add age 3 years to whatever was Jane's age. So this changed Jane's age. It did not give caller anything back. It only changed age of Jane. So that is a mutator. Some methods are neither accessors nor mutators. For example, spot.fetch slippers. Well, it does not change age or spot or whatever variables, okay? But it returns something for me, okay? Like slippers, red slippers, so on, okay? We'll see, this was a small interaction. By the way, this is called sequence diagram. You will have to learn how to draw this. We'll come to that. This particular lesson is mostly about getting used to the terminology, accessor, mutator. Have a look at this again and again just to get used to the terminology. We'll come back to a new example, design of a television class. Until then.